All right, so welcome to today's session of the Domino-E webinar series. It's the second of 3 sessions. For those of you who've already joined last week's session, welcome again. For all people attending who are here for the first time, nice to see you. We will today take a closer look at 3 actual dominoes, at examples for dominoes that have been developed under the framework of the Domino-E project. So last week, what we did was set the baseline and have an explanation of the overall domino architecture for European Earth observation ground segments. This week, we will look at actual domino developments undertaken in the Domino-E project. Michael, fill us in on what happened last week and what's the plan for today.
Yeah, before we start with the actual presentation for today, I just want to have a quick reminder of what Domino-E is actually all about. Domino-E is a European Commission-funded project that is where people from 7 partners located in 5 countries are actually working together to create a modular federated ground segment architecture for Earth observation. The goal of this Earth observation system that is produced in Domino-E or that is made in Domino-E is to make Earth observation more interoperable, to make it more developer-friendly also, and to make it, most importantly, ready for the future with standardized building blocks called dominoes, and that's what we're talking about today. Now, in our very first session last time, we looked very much at the big picture challenges of Earth observation in the history, but also contemporary challenges. We talked about rising data volumes. We talked about the need for real-time access, for lower costs, and also for greater flexibility that is needed in Earth observation. And we also looked at how domino architecture is designed to actually address all of these needs. You can, of course, rewatch the first session. It is already on YouTube. It is also on the Domino-E website, and you can follow the presentations from last time there. Today, as Thomas already mentioned, we are going to shift a little bit more and look towards the dominoes as such. So we will look at dominoes that are developed within Domino-E. And the next time, and that's the third session, then we will look mainly at the business opportunities that evolve from these Domino-E or the domino architecture. Now, before we go to the overall content for today, just some housekeeping rules. It is a webinar, so it is meant to be interactive, and you are obviously always invited to raise your hands to ask questions. If you feel more comfortable by typing them into the chat, just use the chat function. I think you're all familiar with that, and we will just read out the questions that are have been shared in the chat. So both options are possible here. During the presentations, we would just remind you to keep your microphones muted so that all the presentations can go on smoothly. And last but not least, since we will make also this presentation available for the recording for rewatching on YouTube again, and also on our Domino-E website. This whole session will be recorded, and I hope that is fine with you. And yeah, that's it from the housekeeping. I think we can basically go to what we are going to explore in the very next 90 minutes. We will start with a very, very brief discussion once again on what actually is the domino architecture and what makes a domino. So Jean-François Vinuesa from Airbus did a very nice presentation on that last time, but in order to have everybody on the same stage, or on the same page here, we will do a very brief introduction on these two very topics once again in the beginning. And then we will have colleagues from the project, from Airbus, from ITTI, from ONERA, from Capgemini, from Tilde, from basically 6 different partners all over Europe that are contributing to the Domino project, and they will explain the very dominoes that they are developing by themselves within Domino-E. So, what is a domino, and maybe also before that, what is the domino architecture? Before we get into the individual applications and also the real-world examples that are developed within Domino-E, I would like to recap a little bit the core ideas that are standing behind the Domino architecture. So Domino is basically a modular and a flexible ground system architecture that is made up of individual building blocks, and each of these building blocks is called or equals to a domino. And each of these dominoes can be customized for very specific functions, for very specific tasks. And these tasks range from image quality, from image processing, but also to satellite tasking, to communication, to system orchestration, also to security issues and measures. So you see that some of the dominoes are focused very much on the core ground system operations, like managing the data flows, optimizing the scheduling, improving how data is processed and also delivered. And some others are dedicated more to the constellation management, helping to coordinate and allocating resources across multiple satellites. Right now, the Domino framework supports mainly optical Earth observation systems, including both high resolution and very high resolution constellation. This may change in future, so there is a good reason also to think that the Domino architecture will soon be applied or possible also for radar constellation. And it is in these terms basically designed for the future. It is scalable, and there is also a clear roadmap to upscale the whole Domino architecture. One of the key strengths of Domino is the multi-mission capability of this architecture, meaning that it is not tied to a single satellite or to a single operator, but instead it very much promotes cross-communication between different missions, and that allows for more efficient use of assets and a greater operational flexibility. So what exactly is a domino within this architecture? Think of a domino as a sort of a self-contained building block within an Earth observation ground system, and each of these dominoes is designed to perform a specific task or set of tasks, either for a single mission or across multiple missions. So dominoes are basically modular and they are adaptable, meaning that they can be developed and maintained independently. They are deployed independently without depending on or disrupting the rest of the system. So you can plug them in, but also take them out again. And this gives us a low coupling and makes integration much, much easier. Dominoes are also customizable and they are also scalable, meaning that they can include mandatory core functions along with optional extensions that are based on specific missions and customer needs. And they can be delivered either as a standalone product, but also as a service. And that depends very much on the deployment model that is applied. And finally then, dominoes are cloud native. So they can be deployed both on premises or in a public or hybrid cloud environment, which makes them highly scalable, but also performance flexible. Now, altogether, this approach that has been chosen for the Domino architecture allows developers, operators, and also third-party contributors to build, to plug in, and to evolve Earth observation capabilities in a more agile and a more interoperable way. For a more technical and for a more detailed explanation here, I would invite you very much to watch or to re-watch the presentation once again from Jeff Vinuesa that was given at the last session. So this is basically a sum up here without any claim for completeness at this point. Also, Jean-François was giving some insights on the technical qualities that each of these dominoes needs to fulfill. Yeah, with this in mind, I think we are good to go for the actual examples.
Sure.
And I hand over to you again.
Yeah, I mean, we do have with us representatives from more than 3 companies, but representing the development teams behind 3 actual dominoes. And today's webinar series, it's online, obviously, but it spans from Toulouse in the south of France to the beautiful middle European cities of Poznan in Poland, where ITTI is based. We have Jakub with us, I see him on camera. And also we have Raivis Skadins with us from Riga in Latvia. And also we ourselves here in Vienna, sort of in middle Europe. So it's quite a pan-European project, and those 3 dominoes to be presented now will show you how there's contributors from all over Europe to the modular architecture, which shows you clearly how modular it is. It allows, the domino architecture allows people to contribute to the development of segments wherever they are, which is a good thing. And I think we delve into the first domino, which is the satellite communication and research and resource management domino. There's a lot of abbreviations coming towards us. It's the SCRMS.
So I'm Philippe Babiro. I work at Airbus Defence and Space. I'm an engineer in the mission algorithms for Earth observation team.
I am Jakub Rezler. I work at ITTI and I am a system analyst. SCRMS, in most simple terms, it's a schedule maker for the communication between satellites and ground stations.
The idea is to plan the communications between the ground and the satellite in both ways. In the upload way, the goal is to upload the telecommand plan of the satellite, what it should do. And in the download way, well, it's to download images. What our domino does is taking into account the orbits of the different satellites it manages, the position of all the stations, and produce a plan with no conflicts between the different communications.
It organizes the meetings between the ground stations and the satellites so that we know when those meetings can be, when those meetings will be. That is what SCRMS, what it handles. In most simple terms, we allow the users, the owners of the ground station of the satellites, to pool their resources together.
Let's imagine a situation with a disaster. So we have the capacity to take images from space, but there are constraints to using the space assets. If the disaster happens 3 hours after you have uploaded the plan, you have no reactivity, you cannot do anything. So what our domino provides is a capacity to be much more reactive.
It's there are simply a lot of variables at play here. I mean, even the simple basic situation of a single constellation belonging to this user, even that is already complex on its own. So I suppose one of the key problems that we are grappling with is simply the fact that there are lots of different elements.
This capacity of communication between the satellites and stations, this is quite new, but there is also a cost impact. Or you can use the network providers that will loan their stations to you. And by using that, you don't need to invest in your own hardware station. So you can decrease the cost to access space.
Yeah, now you've seen Philippe and Jakub from the Domino-E team. They have introduced themselves in the short video. I would ask them to please reintroduce yourselves here now live on cam. That having said, I think Philippe doesn't have a cam at ADS today, but you see Jakub on your screens already. Jakub, the floor is yours, and also yours, Philippe.
All right, I guess I'll start. I am Jakub Ressler. I am a system analyst at ITTI, and I work at the project Domino-E, specifically the SCRMS module. ITTI is responsible for the final implementation of the module. We taking the design from Airbus, we taking the algorithms from ONERA, and we make it into the final product.
Yeah, hello. So I'm Philippe Avero. I work on the mission planning algorithm for Earth observation team in Airbus Defence and Space. And I've worked mostly on the design and coordination with our partners.
All right, thank you. So I think you've prepared a little presentation that allows us to look into a bit more detailed view of the SCRMS Domino. Please share your insights.
All right, so I will start by re-explaining what the SCRMS does. So SCRMS stands for Satellite Communication and Resource Management Service. Here we'll focus on the communication part. So the SCRMS is a multi-mission domino. So on the one part, we have multiple constellations. And on the other part, we have own station and ground station as a service networks, where we can loan slots for external commercial stations. These external partners, they will have their own specificities, such as cost and how we can interact with them, how we can book contacts, and that is what will be handled by the SCRMS. So the goal for the SCRMS is to produce a communication plan which minimizes the cost, or also minimizes the conflicts between communication slots. And this relies on algorithms that were developed by ONERA and also on our Domino shell that was developed by ITTI. And finally, one last thing, an important thing that is handled by the SCRMS is the workload. So the quantity and qualities of the communication plan are highly dependent on the satellite workload. So it adapts the communication plan to this workload level, so that the communication plan is still meeting the minimum cost and conflicts. Maybe Jakub, if you want to say a word.
All right. So I suppose to focus more on the technical development, the technical side of how it's actually made. So as far as the first testing, as far as actually developing the SCRMS is concerned, there are two main parts. There's of course the SCRMS itself, the module, and there's essentially everything else that is the simulators. In short, SCRMS is meant, like entirety of Domino, is meant to be a number of interconnected elements. But right now, we are kind of one of the first elements to exist. So in order to actually test how it would work in actual ecosystem, we have to make those other dominoes, those other modules, and make simulators of them, a little mock-ups that are meant to simulate their behavior, their intended behavior. And essentially that is how it is currently designed as a SCRMS, and there are a bunch of other little programs that pretend that they're the other dominoes, and that is how that is essentially how the standalone tests work currently.
Maybe we can move on to the next slide. All right, Jakub, do you want to start?
Right, yes. So if I were to sum up the main challenges that our work here faced, I think I can sum it up in really just one word: communication. There was and is an absolute massive amount of communication needed in order to, well, for one, in order to comprehend what are we supposed to do. I mean, I'm pretty sure I'm like responsible for half the emails that were sent during the development of this module, simply because my company, need kind of to fully understand, to grasp how it's supposed to work. Even once we got the documentation of how it's supposed to work, once you go below a certain level of abstraction, there are just so many little details that are necessary to be not only to get knowledge of how exactly they're supposed to work, but oftentimes to decide how they're supposed to work when the design decision isn't obvious. And well, furthermore, it wasn't just I suppose there are three parties here as far as Domino is concerned. Like as far as SCRMS itself is concerned, there was of course the Airbus Philip, there are ITTI, so mostly me, but also my developers, and of course there was ONERA. And this three-way communication was, well, it was another complicating factor here because, for example, let's say me and Philip communicated. We had a meeting about a certain design decision. Okay, well, those design decisions have to be trickled down to, first of all, my developers. They have to trickle down to ONERA. We have to make sure that everyone is on the same page. And, well, as I said, there's just a lot of communication involved, lots of finding, of making sure we know how it's supposed to work, of finding out at times how it's supposed to work, and making sure that everyone knows how it's supposed to work. And once we get into the end-to-end scenario, so to explain, there are two types of scenario here. There's the standalone scenario, so we have the SCRMS itself and the simulators, and there's the end-to-end scenario, that is SCRMS, all the other modules that are actually made by other teams, or simulators, their simulators, and we are all supposed to work together. And at this point, well, it's an additional layer of communication, of complication, of making sure that all of us are capable of, well, that reaching all of us, all the companies here can work together, that they, well, again, that they are on the same page. And Philippe, do you have anything to add here?
Yeah, probably that I was responsible for the second half of the emails, along with ONERA responsible for the third half, probably.
Yeah.
So yeah, I agree that the coordination was a strong point that we had to address. But I want also to stress that it was a great collaboration, and that I think the Domino is better for all three partners. We have tried to bring at Airbus sound design and to define the direction that we want the insides of the SCRMS to take. But as you said, we had a lot of coordination, but that also means that the design was enriched by all the questions and all the problem tackling that we did. So, of course, ONERA was invaluable in making the algorithms. They developed, defined the mathematical problem and explored many different algorithms types that could solve this problem. And on the other hand, ITTI, you were indispensable to make it happen in the real life and help us see all the details that were coming from using the actual domino architecture. So yeah, there was a lot of coordination needed, but I think the final product really benefited from this cooperation. So yeah, that's the third point that was that is written here on the slide. We have the domino architecture, and we will be testing it, as you said, in the end-to-end scenario test. But it defines the APIs and main functions. So we really have to go into the details to define what has to be developed inside the domino. We are really responsible for the internal workings of the domino. So that's what Michael said at the beginning. The domino is a self-contained component of the ground segment. And by this self-contained, this entails the responsibility to develop the inside works. And we could have stopped at something very simple, but here we went all the way to handling multiple constellations and multiple networks, own station, as well as GSAS stations. And this induces a lot of complexity. So one word on the end-to-end tests. I just want to add to what you said that yeah, we are still using simulators, but we want to integrate the three dominoes so that we can achieve the best technical readiness level for integrating the dominoes into an actual commercial proposition, commercial product. Yeah, maybe we can move to the third slide. And so, yeah, go ahead.
I'll start by saying that, well, as far as our recommendations go, our main recommendation is that, well, as I said, there is plenty of communication needed. Most of that communication was necessary for simply sharing of knowledge, of gaining knowledge, of generating new knowledge when we had certain design decisions to make. And most of that knowledge is essentially written down. There are plenty of reference materials available on the website of Domino-E.eu. There's of course the white paper, there are the design documentations, there are applications, presentations. There's essentially plenty of material, and if you are going to try to make your own domino, you don't have to start from scratch. There's, well, not sure if you want to make SCRMS 2.0, but if you want to make something else, you have reference materials of how it went for us, of what decisions we made on even the lowest level of abstractions. I mean, we made it, it works. So it's essentially a starting point that you don't have to start from scratch. There's already work done. There's already work available to reference.
Yeah, and as well, we have used a lot of simulators, but now that there are Dominoes existing, it will be easier and easier to go into a full ground system, and to test the APIs, it might be easier. And we also have a cloud working. So all these implementations and testing that we have done, they are available, as Jakub said, on the domino-e.eu website. So it might help and facilitate the easing into the Domino world. So yeah, maybe that's it for us. So if you have any questions, and yeah, I will just give the mic back to Thomas, and we can proceed.
Yeah, thank you to the both of you. You already said it. Floor is open to everyone who wants to ask a question. Maybe we let everyone think if there's open points. What I wanted to say is that I like the way you presented this and gave an insight into the actual work on a Domino, because we do talk a lot here about the openness of the system, the platform, the shared interfaces, shared standards. But still, in the end, it doesn't mean you can just begin working on your Domino. It still needs a lot of collaboration. And I think this is what you explained in a very nice way when you mentioned the amount of emails that was necessary to get the work started and to actually work on something meaningful in a collaborative way. Are there any questions from the audience at this point? Well, there's not too many. Maybe from our end, Michael.
Yes. So still feel free to type your questions also in the chat if you have any. I was wondering, last time or in the first session of this webinar, we have been discussing also the traditional tasking loop. So I'm now getting a little bit back once again to the more technical aspect, or maybe also to the use case as such. So the traditional tasking loop, starting from the user request, then the data upload or the processing of that request, uploading the data to the satellite constellation, then download or taking the image, of course, downloading this data and delivering the final image. And we also mentioned in the context of this tasking loop or the classical tasking loop that this is taking up to 3 hours with standard constellations that we can see today. So my question would be, if you have any idea on how much or to what extent the SCRMS, that I understand as a more federated way also to upload and download data, whether it improves the reactivity or how it improves the reactivity and the responsiveness in comparison probably to these very traditional tasking systems. And if you could just elaborate a little bit more on this particular technical aspect, if that would be okay.
Yeah, sure. So we'll take this one. Maybe Jakub will have something to add. So on reactivity, this is one of the main goals of the SCRMS. So if we take, first we'll talk about traditional mission, and then we'll see what our Domino improves with regard to reactivity. So on traditional mission, let's say you have 1 or 2 satellites, and you have one owned station in your country. Usually, your satellites will see the station once or twice in the morning, and then once or twice 12 hours later. So that means if something happens somewhere in the world, you are forced to wait for those visibilities, those slots, to change the plan of the satellites. You also have no way of communicating. You have no built-in way to communicate with your satellite outside of those predefined station slots, and they are defined for the whole life of the satellite. with the SCRMS, you have several additions to this work that will help with reactivity. First thing is you can use commercial stations that will be using the ground station as a service function. And this means that you can use stations that are built everywhere in the world. If you can go back to 2 slides earlier, that will be more visual. Yeah, thank you. So let's take the example on the world map here. You have the station in Sudan, and if you have only this station, you will see it on 2 slots, so one morning, one night. With the other station that are defined as the yellowish round polygons, you see that the satellite will fly above the stations several times a day at different periods. So that means if the workload evolves and you want to, let's say, acquire pictures of the Southeast Asia area, for example, then you can start using the station in, which is, if I remember well, it's in Kuala Lumpur, so very close to the area. And that means you will get your images downloaded much, much earlier. You don't have to wait for your satellite to fly above your own station. Also, you can add a station that will be seen before the flying over this area. And that means maybe you can upload a plan only an hour before you fly over this area. And that means several things. First, it means that you can adapt the acquisitions at the last hour, maybe not last minute, but close to, instead of last 10 hours, for instance. And also it means that you can have an updated weather prediction, which means that the images you prepare to take have a much higher chance of success. So you won't be imaging clouds. And with those two possibilities, the SCRMS can adapt the contact plan so that you can reduce the reactivity. So tasking at the last moment and getting the images as soon as possible. And one thing I have to add to this picture is that usually the own station is a simple, well, it's not moving, and we have no way of to be flexible with the download plan, which means it's settled at the beginning of the project, and you just have to adapt it little seconds by little seconds. But here you have a complexity, much higher complexity, because we have several stations, multiple constellations, multiple satellites, and you want to adapt for the contact plan for all these elements. So that means it is not doable at the beginning of the project, of course, and it's also very difficult to do it manually. So the SCRMS has the automation of this process so that the contact plan can still be computed at the last moment and updated, thanks to the algorithms and architecture that provides this capacity.
Thanks,
I
Philippe. I think...
will also add
sorry.
one more thing that is as a little reference, as a time reference. How much time does it take for SCRMS to work? I won't be saying for the whole process from beginning to end, because we have yet to go through the end-to-end test. But as far as SCRMS part is concerned, it is part from SCRMS, from the beginning of SCRMS is informed that the satellite needs to have its needs fulfilled, the needs for contacts. Actually, not just a single satellite, more like multiple constellations are informing SCRMS that they have certain needs that need to be fulfilled, and we have multiple stations among those stations not even owned by the owners of the constellation. So a more complicated scenario. Even that scenario, it is still done as in SCRMS it organizes a plan of contacts, it books those contacts, assuming they can be booked at a given moment. That part is done essentially in minutes. So yeah, it's quite fast.
All right, thanks for your explanations. I think now it became quite practical and tangible for the people, which is always good to work with concrete examples here. And I think now it will get even a bit more practical, since the second domino we will take a closer look at points more at the core of what Earth observation is about, at least that's my understanding as a layperson. We will look into the coverage service, which is actually about taking images the best way, and an algorithmical model for optimizing the coverage itself. Before we delve into a presentation by Marie Devant, Cédric Pralet, and Cyril Delucy, let's have another look at a short video, and this time in advance, let me apologize for the potential delay of the sound.
So I'm Gauthier Picard. I'm a senior research scientist at ONERA.
My name is Cédric Pralet, and we are in a department called the Information Processing and Systems.
I'm Marie Devant, and I work at Capgemini as a product owner for the coverage service application.
In the coverage service is how to split large areas into subregions and assign the subregions to different missions.
So the coverage service application is an application which aims at providing for a huge area the most efficient dispatch between mission chains to take the picture more efficiently.
For instance, if you want to monitor a phenomena on Earth that requires to be frequently observed, we can say, for instance, maybe biodiversity, but also just a phenomena like fires or growing of urbanization, and you want to frequently pass, and maybe at some point, if there is one point of a phenomena that is diverging, you want to follow this like a fire which is spreading and at some point is going elsewhere. You want to keep track of this to follow the phenomena as fast as this phenomena is evolving. Okay, so it requires reactivity and to be able to acquire large-scale area very fast.
Imagine you have a small area to cover. To cover this small area, the satellites will perform small images, and if you have a very small area, maybe you need something like 10 images to cover the area. And suppose you have two systems, system A and B. One question is, how do I dispatch my 10 images over the two systems? And the number of possible dispatch decision is 2 to the power of 10, that is about 1000. This is already quite big, but imagine now that we have a larger area requiring something like 60 images. In this case, if you still have two systems, you have 2 to the power 60 possible dispatch decisions, which is billions possible decisions, and our goal is to find one solution that has a good quality among these possible decisions.
The coverage service originally was a prototype But we decided to go a bit further and to build the coverage service application with the same standard that we use for other operational systems. And so we're trying to develop an application which is as close as possible to an operational system.
We are doing very fundamental research about the algorithmics behind these decision problems, and we assess the performances of these algorithms using real data. So in the Domino project, we have access to the real configurations of the constellations. We can have access to realistic order books so that we can fine-tune our algorithms using this real data.
It's like a game, and to play this game, we develop algorithms to search as efficiently as possible.
All right, so that was a little introduction to the coverage service. We will now have a short presentation by Cédric, by Marie, and also by Cyril de Lucie. You may have witnessed in the video there was Gauthier Picard of ONERA. He's not here with us today. Yeah, please give us a short introduction into who you are, what's your roles at ONERA, at ADS, and also at Capgemini this time.
Okay, I guess I take the lead then. So I'm Marie, hello, and I work on the development of the coverage service application, which integrates the algorithmic solution that Cédric and Cyril have developed. I'll let them introduce themselves.
Well, hello, I'm Cyril, so from ADS. I work in the same team as Philippe Pavero that you've heard earlier, so on the mission planification algorithms, and I've worked on the development of one of the solutions for the coverage service.
Hi, I'm Cédric Pralet from ONERA, and I worked on algorithms for the coverage service for a second solution, and that was my job in Domino.
Okay, I think you have also prepared some slides. I'll leave it to you to let us know when we should skip the slides, and yeah, you know your slides best, I guess.
Okay, so I'm going then. So we are going to introduce you to the coverage service application and explain to you what were the main challenges during the development of the application, but also during the algorithmic solution development. So next slide, please. To reintroduce you a bit what the coverage service application does. So it's part of the Domino architecture. To create the link with the previous slide, it's a part of the multi-mission service Domino, more precisely to the Federation service Domino. So it offers some of the functionalities that those Domino have been defined to do. So the coverage service is, its goal is to minimize the time of completion of a coverage request while optimizing the load balancing over systems, which means that you have a large area to cover, you submit it, and the two algorithmic solutions that ADS and the ONERA have developed will create a dispatch of this area that will be requested to several mission chains. So to give you a quick look to the algorithmic solution, the ADS one will subdivide all the area into smaller areas and dispatch them among the system. And with the ONERA algorithmic solution, it uses meshes and accesses computation to dispatch the workload directly at the mesh level. So it's more precise, but maybe a little less robust. So they will talk about it later on the slide. If we can switch on the next one, I will talk a bit more about the cover service application, which integrates the two algorithmic solution. So to build our cover service, we have taken into account the domino constraints, which are the standardized API. We other external system, which are the UAS for user access service, and also external mission chain and sovereign mission chains. So we have built an application that satisfies the API that have been defined to interact with those external systems. Another constraint was the deployment on a cloud environment. So we decided to build the cover service on a microservices architecture. So each services is inside Docker images that can be deployed either on our internal platform or on a cloud platform. We also decided to choose this microservices architecture because we are integrating two algorithmic solutions, and so we decided to integrate them into small boxes, which are Docker images, and so they are interchangeable. So if we want to test the ADS algorithmic solution, we deploy only the Docker image that contains those algorithm, and we launch our test with this box. And if we want to test the ONERA one, then we change it, and it allows us to have interchangeable smaller parts of our application. That's what we decided to build with this architecture. The main challenges was obviously the integration of those two algorithmic solutions, because we have to design it in a way that all the similar things will be reused, and all the differences will have specificities. So we thought a lot about what was similar and what was different between all the two algorithmic solutions. So it was a real design work to do. And we also I've decided to test those algorithmic solution with real sovereign mission chains, because we had the possibility to do so. And one of the major goals of the development of the cover service application was to make it as operational as possible. So we tried to make the cover service to plug the cover service with real sovereign mission chains, to be able to compare the planification of the cover service and the planification of a real mission chain. So that was another big challenge to address. And I think that's all for me. If Cedric or Cyril wants to add something for the next slide, maybe.
Yes. So the main message of this slide is to show that within each domino, you can encapsulate your own algorithms, and even if the problem to solve is complex. So here on the video, you see our domino running, our algorithms running on an area which is Croatia. And the algorithms are dispatching this area to two systems, one in green and one in yellow. So we have meshes that are dispatched to the system. And for the algorithms, there are several challenges that we have tackled. First, the optimization problem solved are very large optimization problems, because we have thousands of candidate meshes to dispatch. We deal with a large area which require long coverage completion times. And it's not possible to explore all the possible solutions, which is why we have developed fast optimization techniques that are encapsulated within the dominoes. Also, as mentioned by Marie, we have multiple objectives, such as minimizing the completion time of the whole area, or minimizing the overlap between the selected meshes, and so on. And to deal with these objectives, we use some expert decision rules that are encoded within the Domino. And we also have some randomization to explore diverse solutions. And last point, we thanks to the Domino that we developed, we are able to manage several sources of uncertainty due to first the cloud coverage that could lead to failed images. And also, when we dispatch some meshes to some systems, we do not have a full control of what the system will do with the mesh. And we have these uncertainties, and to cope with them, we have developed dispatch and redispatch strategies to take into account the current progress of the mission. So again, the main message was to show that within each Domino, you can encapsulate quite complex procedures to answer to the needs of the missions. And that's it for me.
And I guess that's it for us, even. So if you have a question, or if Cyril want to add something.
Well, just wanted to remind you of the two algorithms. So there was one developed by ADS and one developed by the ONERA. And the idea is to answer the issue in two different ways. Actually, ADS algorithm is more coarse-grained, so we expect it to be less optimized than the ONERA. And the ONERA is a more detailed, does the dispatching in a more detailed, more precise way, so more optimized. Sorry. Yes, that's all for me.
All right, thanks to the three of you. Fascinating, complex work, definitely. Let's wait for another second if there's someone wanting to ask anything. And otherwise, I'd suggest we take that as a good sign, and you've explained it all crystal clear, and there's no open questions remaining. Looks like there are no questions. Then thanks again. And it's time to take a look at the third Domino that's been developed under the framework of the Domino-E project, and that's a virtual assistant service. We call it VAS internally, and we have at ITTI Gadins with us. I hope I'm saying this halfway correctly. Otherwise, fill us in on how to pronounce it correctly. And yeah, as usual, we watch a little introduction video, and then after that, floor is yours for a presentation.
My name is Skadinch. You are at Tilde. We have always been working with language technologies. In Domino-E, we are building virtual assistant that is aimed to help users to communicate with sophisticated system. So if I want to, for some reason, to see my municipality from space, I cannot order these pictures because I do not know where to go, what information I should have. I even do not know what questions to ask. Virtual assistant will help you formulate your needs. If we want to have more customers, we need more support people. And but here, by introducing virtual assistant, we hope that these operators will be able to serve more clients. Everybody is building their component. So people from coverage service or multi-mission service, they are building their part, and this part is constantly changing. Other people are building their part, and it is constantly changing. So, and we are building user interface to constantly changing thing. So we have to adjust to this continuously changing environment. Yes, that's so far, and I think we have some challenges ahead of us, because when real operators and end users will start using this system, we will discover new challenges, because so far we have built this virtual assistant based on our expectations how end users will use it. But then when we will invite real end users, we will discover that they look to the system from different perspective. We started this project before ChatGPT was released. So this generative AI has been developing so rapidly. We understood we have to include it in our project, because otherwise our project is built on old technology. So we made some adjustments in our research that really included generative AI, and that allows us to build more robust virtual assistant. I hope that you can impact what's going in orbit by chatting with virtual assistant. So you chat with virtual assistant, you explain your need, virtual assistant asks you some additional questions just to be sure that we are both thinking about the same thing. And if we agree that you really need that picture, satellite changes its orbit and takes your picture. So that's so exciting.
Okay, so that was the little introduction video for the virtual assistant service, and I think it shows you quite well that, like, 3 years ago, when the proposal for the Domino-E project was elaborated, it was really looking into the future, and it doesn't feel like looking into the future that much today, as you've mentioned in that little interview sequence, Raivis. But explain a bit more to us. What's the development of the VAS like? What's it about? And also, who are you and what's Tilde?
Yeah. So, good morning. I'm Raivis Skadiņš from company Tilde. We work on language technologies, different kinds of language technologies, like proofing tools, machine translations, speech technology, and also we are working on virtual assistants. So it's not so easy to continue telling you what is virtual assistant after such a great introduction, because quite a lot has been said already. But let's continue with next slide. So how we see how virtual assistant fits in this big picture. So from one side, there are users, end users, who really want to get some pictures from space, want to see what's going on here on Earth. And from other side, there are all these sophisticated systems with many constellations of different satellites, different missions and antennas, all kinds of ground segment systems. And there is a big gap between those two, between users and ground segment systems. And virtual assistant, as a part of user access service Domino, stands in the middle between those two. So we are aiming to offer conversational user interface powered by generative AI, so that this communication between end users and ground segment systems would be more intuitive and efficient. So there has been big hype about artificial intelligence during last years. So everybody has tried systems like ChatGPT and discovered that these systems, at least to some applications, are very smart and surprisingly good. So, and if we can go to the next slide, then probably I have to mention that the most important thing that virtual assistants provide is ability to communicate with users in users' language. So these systems are not expecting end users to use correct terminology. No, that these users will understand all processes that are behind these sophisticated systems, or that they will know everything about all possible parameters and data sources. No, these systems are there to guide users, to explain what options they have, to suggest what parameters could be used, explaining what each parameter means, and these systems keep track of the whole conversation, so that at any given moment these systems know what's going on, what user has asked, and what's going next, what next options the systems could offer to user based on current conversation about current context. And what's interesting is that the systems continuously learn from users and domain experts. So the systems keep track of challenges users experience, of unanswered questions, unclear processes where to go, and then domain experts and virtual assistant trainers can analyze these situations and improve conversation between user and system by adding more knowledge into knowledge base, or defining some new scenarios, how to guide the users through this conversation. And at the end, we can look on these systems like on translators or mediators who discuss with the user in user language, and then transform this knowledge collected from user into precise technical queries, precise technical terms that can be sent to satellites, sent to planning systems, and at the end something happens. User gets automated execution of his query. He can order some picture or order some acquisition of new pictures. And please let's go to third slide. Then I would like to go a little bit up on the other level of benefits. So if you look on benefits from business perspective, so virtual assistants allow to lower access barriers for the end users. So we can bring in new end users who would not be able to access systems without such tools that help them. So we democratize access to Earth observations. More users can be served, and such virtual assistant also improves understanding of satellite-based imaging. So whenever user has some question, he doesn't understand something, there is virtual assistant who can try to answer these questions. And these assistants can be trained on all kinds of sophisticated materials, all kind of user manuals, technical support information, and these assistants can answer questions using this knowledge base. And at the end, I think it increases efficiency of operators who are serving Earth observation clients, and we also increase user support level, so users can get more information, sometimes even just by themselves, by talking to virtual assistants. We do not need to involve real human operators, human user support people to answer simpler questions. We can allow humans to focus on really advanced questions, so where we really see added value from real human communication. And finally, at the end, so we see that such virtual assistant service that utilizes artificial intelligence, modern technologies, can unleash potential of Earth observations. So more people can access images they need from different sectors, from public sector, from businesses, and even end users, citizens can benefit from such systems.
All right, thanks you, Airbus, for your explanations of the virtual assistant. Again, let's see if there's questions in relation to that. Also very fascinating work. And otherwise, I'd take the liberty to ask something. And this is about the end users you have in mind. You mentioned the end users a lot. Who is it you imagine as an end user? Is it usually professionals who are already very familiar with Earth observation, image generation requests, or is it lay people who want to acquire some imagery and have never done that before? Because this question, I think, is also linked with the access point. Where would they find the virtual assistant? Maybe you can.
Yes, this is completely new direction, and I think at the moment we have to really evaluate this virtual assistant to see, to really understand who is its real user. So initially, it's clear that this technology will be used by professionals, operators who are working with ground segment systems, and they can explore real capacities of such assistant and evaluate whether we can bring in new groups of people, maybe with lower initial knowledge. So, and to some extent, these new users can work autonomously. Maybe we need some final approval from professionals at the later stage. But yeah, as I already told in this introduction section, when we will really start using this virtual assistant, we will really discover how users are working with it, and what users will ask to it, and what will be strengths of such solution or weaknesses, and then we will really understand user. But I would be glad to have any user who just needs his picture of his area of interest. But of course, we have to to understand how we are building business models here. So because these are not always very cheap systems. These are systems that has needs a business model to implement.
All right, thanks. So we'll see there's still some open questions to be answered in the very near future, not necessarily within Domino-E. Do I get you right? Yeah. Okay. So I think floor is still open for potential questions. If there's anyone wanting to ask something to Raivis or also to the other presenters that have presented the Dominoes earlier. And otherwise, we go back to housekeeping and hand over to Michael again.
Yeah, so I think what Raivis mentioned in his very last sentence or part of his answer to the question was already pointing us to the next session of this Domino-E webinar series. Today, we had the chance to actually look a little bit on the modularity, to learn also a little bit about what are the technical requirements, the restraints that within which these dominoes need to be developed, or not just the dominoes, but the dominoes as building blocks need to be developed in order to be integrated or potentially be integrated into the domino architecture. Next time, we will look very much at the business opportunities that arise from these dominoes and from this very architecture. So now that we have understood what is the overall idea of the architecture, what is the idea of the dominoes as such, we will have a deep dive on the business opportunities. You can already use this link also to register here to scan it and register on Eventbrite. The presenters for next time will be Amaya Atencia-Yepes from GMB in Madrid, and then we will also have a presentation from Jean-François Minuesa, once again, particularly focusing on how to onboard also, not just SMEs, but whoever is interested in developing dominoes for the domino environment. Yeah, we are a little bit ahead of time. However, from my point of view, I would like to thank you, particularly also the presenters for today, for sharing their knowledge with us, for providing some insights also to the particular dominoes, and of course also to the audience.
Yeah. So there's not much left to say. Have a pleasant week. Have a pleasant weekend. See you next week.